In this video, we want to work on Senior Mathematical Challenge 2022 solutions, and we want to find background ideas for the problems, and also I will leave some related homeworks for the problems that are important. Let's try. From first problem, it says when the expression 2 squared minus 1 times 3 squared minus 1 times 4 squared minus 1 times 5 squared minus 1 all over 2 times 3 times 3 times 4 times 4 times 5 times 5 times 6 is simplified. Which of the following is obtained? Okay, here we can multiply, or for example, 2 squared minus 1, 3, and simplify. One other way is to use this identity. That x squared minus y squared is x minus y times x plus y. If we use that, it will be 2 minus 1 times 2 plus 1 times 3 squared minus 1 is 3 minus 1. 3 plus 1 times 4 squared minus 1. 4 squared minus 1 is 4 minus 1 times 4 plus 1. 5 squared minus 1 is 5 minus 1, 5 plus 1. All over 2 times 3 times 3 times 4 times 4 times 5 times 5 times 6. Okay, 6 here is 5 plus 1, 6, 5, 4 plus 1, 5, 4, 3 plus 1, 4, 4, 5 minus 1, 4, 3, 4 minus 1, 3, 3, 2 plus 1, 3, 2, 3 minus 1, 2, 2 minus 1. Here, 2 minus 1 is 1, numerator is 1, denominator is 5, 1 over 5. So the answer is D. Let's try second problem. These things that you can cancel, sometimes we call it telescoping product. And okay. So let me tell you a problem as homework to use telescoping sum. Homework 1. The background idea in these types of problem that you can cancel is telescoping rule. Sometimes sum, sometimes product. This problem as homework 1, AMC 2022 10B problem 9. Try this problem as homework. So let me write it. AMC 10B 2022. AMC 10B 2022 problem number 9. You can try this problem as homework. If you wanted to learn more ideas like this, 40, 50 important ideas in each topic, feel free to send message to my WhatsApp number in the description and comments. Let's try second problem. What is the smallest prime, which is the sum of 5 different primes? Okay, let's see the choices. Let's first find some examples, considering some examples. 2, 3, 5. The smallest 5 primes are 2, 3, 5, 7, 11. If we add 2 plus 3, 5, plus 5, 10, 17, 28, 7, 28. So the smallest number that we can create is this. So let's write 2, 3, 5, 7, 11, 13, 15, 17, 19, 21, 23, 27, 29, 31. Okay. So we can change some of them. If we want to reach, for example, 39 is the smallest. Okay. And but it says what is the smallest prime? 39 is not prime. 41 is prime. So let's see, can we create 41? If we want to reach from 28, we need what? To reach this part, 2, 12, 13. We need 13. Okay, now, because the sum should be prime, we should start from 3. Because if we have 2, 4 odds plus 2 will be even. So if we consider the smallest case, 3 plus 5 plus 7 plus 11 plus 13. Again, if we add, it's 24, 31, 36, 39. So 39 not possible. So if we want to reach 41, we need two more. So if we use 17 and some of these things, it will be large for 41. So we should add one of them by 2. So all of them 5, 7 by 2, 9, 3 by 2, 5. It's not possible. 11 by 2, 13. 13 by 2, 15. So if we want to reach 41, we can change only one of them because they are the 5 smallest odd primes. We can change only one of them, so we should increase. Okay, because this is the smallest case. And if we change two of them, then it will be added at least 4. So we cannot reach 41. So we have to change one of them. The only possible case is to change 13 to 15, but 15 is not prime. 13 to 15, which is not possible. 11 to 13, we have 13. 7 to 9, again, not possible. 7 to 9. Okay, so 41 is not possible. If we want to reach 43, we can add 13 to 17. Add 4 to 13, which is 17. So 3 plus 5 plus 7 plus 11 plus 7. It's 28, 35, 40, 43. So the answer is choice C. Okay, we had also some problems related to primes, and also you should use in some of them identities, some of them modula. If you want to learn important ideas in primes, pay attention to parity here. It's so much useful in problems that are related to prime. Parity means odd or even. Here we've understood that we cannot use two, all of them should be odd. If you want to learn important ideas about primes, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay. So it was first idea 1, homework 1. Here, idea 2, second idea. And consider small examples also useful. Let me write I3, considering special cases or small examples. And I4, sometimes we should consider special cases. Like, for example, here that we've considered smallest case. It was problem 2. Let's try problem 3. The figure shows a regular hexagon. How many parallelograms are there in the figure? In this problem, we have 3 directions. This one, let me write the direction. This one, let's check this, and this one. Okay, we consider 2 of them. For example, let's consider this first one, second one, third one. We consider 2 of them, 1 and 2, and then we multiply by 3, choose 2 or 3. We only consider 1 and 2. So when we consider 1 and 2, means we have these lines, and the other lines are like this. This one, this one. Okay. Now, let's consider, we consider cases, okay? So, some problems related to casework. Idea 4. Casework, and then I will tell you a problem from Harvard. HMMT, it will be homework. Let's see how many homework did we have. Homework 1, homework 2. HMMT 2023, Harvard MIT Math Tournament. A problem related to casework. So when we have 1 and 2, let's consider, let's write 1, 1, 1, 2, 1, 3. If we have 1, 1, and 1, 2, okay, these two things. So this is not useful because we are working here. So it can be this part, okay, only this part. So then we can write one case, 1, 1, 1, 3. So here, if we want to use parallelogram, it is not possible. 1, 2, 1, 3. it can be only this. Okay, so one case. So here we have two cases. So 3 choose 2 times 2, it will be what? 3 choose 2 times 2. It will be 6. Okay, so choice C, problem 3. And problem of homework. Okay, you can solve this problem from HMMT 2023 Combinatorics round, problem 2. Okay, you can solve this with caseworks. And one important idea that in casework problems you should pay attention is to when you have casework, priority is, let me write, priority is to use the most limited or restricted case. Okay, and okay, these ideas, and you can solve this problem from Harvard MIT Math Tournament. If you wanted to solve more problems and learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, it was problem 3. Now let's solve problem 4. Okay, problem 4 says the diagram shows two symmetrically placed squares with sides of length 2 and 5. What is the ratio of the area of the small square to that of the shaded region? Okay, this length is 2. Let me write it. It is 2, it is 5. We want to find, it says, what's the ratio of the area of the small square? So, small square is what? It's 2 times 2. 2 squared, which is 4. Over to that of the shaded region. So, if we want to find shaded region, let's divide it into different parts. This one, this one, this one, this one. 2 triangles and 2, we can say, rectangles. This length is what? 5 minus 2 is 3. And they are equal, it is symmetric. So this one is 3 over 2. And in this figure, again, we can say here it is 3 over 2. This length is 2. So if we calculate area, we have 2 triangles, to each of them. 3 over 2 times 3 over 2 over 2. 3 over 2 times 3 over 2 over 2 plus this one 2 times 3 over 2 plus 2 times 3 over 2. Okay, this one again, this length is 3 over 2, this one is 2. Plus, well, because we multiply by 2, we have also 2 rectangles, so we can write like this. Let's simplify. 2 squared is, let's simplify first. 2 squared is 4. These 2 can cancel with these 2 and these 2. 3, 9. 3 times 3, 2 times 2, 4. Plus 2 times 3, 6. Now we multiply both numerator and denominator by 4 to get rid of this denominator. 4 times 4, 9 plus 4 times 6, 24. Okay, sorry, I forgot we calculate this one, this one, this one, this one. Also, we should calculate this one. So we should add, let me move it here. Let's move this part also here. Okay, plus 3 over 2 this part. 3 over 2 times 3 over 2, which is 9 over 4. So we have 9 over 4 here. We multiply by 4, both numerator and denominator, it will be this. So it will be 4 times 4, 9 plus 9, 18, plus 24, 38, 42. If we divide by 2, it will be 21. It will be 2, 2 times 4, 8. 8 over 21, which is choice D. Okay, if you want to learn 40-15 per ideas in geometry, as I said before, feel free to send message to my WhatsApp number. in the description and comments. It was problem 4. Let's try problem 5. What's the value of 1 over 1.01 plus 1 over 1.1 plus 1 over 1 plus 1 over 11 plus 1 over 101? Okay, to get rid of these decimal digits point, we multiply first one, both numerator and denominator by 100, so it will be 100 over 101. For second one, we multiply by 10. It will be 10 over 11. Next one is 1. Next one is 1 over 11. This one is 1 over 101. Now, we consider the fraction with same denominator, 101, 101. Here, 100 plus 1. First and last fraction. Second and second last fractions, the denominators are 11. It will be 10 plus 1. And last one is 1. So it will be 101 over 101 plus 11 over 11 plus 1. 101 over 101 is 1. 11 over 11 is 1 plus 1, 3. Okay, so the answer is choice C. And this one was working with fractions. Multiply both numerator and denominator by same number. If you want to solve harder problems like this, as I said before, related problems from AMC, other prestigious exam, feel free to send message to my WhatsApp number in the description comments. Now next one, related to powers. What's the value of this? 4 to the 800 over 8 to the 400. Okay, so 4 is what? Is 2 squared. We write 2 squared to the 800. Over 8 is what? Is 2 cubed to the 400. Now, by power rule, we know that a to the m to the n equals a to the m times n. So the numerator will be 2 to the 2 times 800 over 2 to the 3 times 400. Again, by power rule, we know a to the m over a to the n equals a to the m minus n. So here it will be 2 to the 2 times, let's write first multiply 1600 over 2 to the 3 times 400, 1200. Now, if you subtract, if you use this power rule, it will be 2 to the 400. So the answer will be E. I want to leave a homework with this idea related to powers. It will be homework number 2 was for HMMT. It is homework number 3. It's for AMC Fall 2021 12B problem number 4. The problem is this. N is 8 to the 2022. Which of the following is equal to n over 4? It is exactly similar to this working with powers. Okay, it was homework 3. If you wanted to solve more homeworks and harder problems, in, for example, exponential functions, more professional topics, and prepare for BMO1, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem 7. In 2021, a first-class postage stamp cost 85 pence, and a second-class postage stamp cost 66 pence. In order to spend an exact number of pounds and to buy, 85 pounds, 85 pence on this, and it says exact number of pounds and to buy at least one of each time. What's the smallest total number of stamps that should be purchased? Okay, let's see. Okay, so suppose we have from this stamp that costs 85 pence, for example, M, and from 66 we have N. We should spend an exact number of pounds. So it will be it should be multiple of 100. Okay? Or we can use divisibility. You should know divisibility, the ideas in divisibility and modulo. Then let me write, it will be idea, what idea 4, idea 5. If you learn how to work with these two tools, there are some tricks. It will be so much helpful. Now here 100 divides. We have a rule that if A divides, for example, AB divides C, then A divides C. So here, 5 divides 100. As you can see, here is multiple of 5. So 5 divides 85m plus 66m. So because 5 divides 85m, you can subtract. Why? Because when we have a divides b, a divides c, we can subtract a divides b minus c. Also, we know a divides a. That's the reason we've used this. We subtract, and then 5 divides 66m. The next one, which we call Euclid's lemma, I'm telling you some ideas that here can be useful by Euclid's lemma. If A divides BC and GCD of A and B is 1, A and B are relatively prime, or highest common factor of A and B is 1, what can we conclude? A and B don't have any common factors, so A divides C. Now here, 5 and 61 are relatively prime, so 5 divides N. Similarly, we can do the same thing. 2 divides this, 2 divides this, so 2 divides this part. 2 and 85 are relatively prime, so 2 divides N. Now, one of them, if, for example, M is 0, let's write 85 on. M is what? M is 2M prime. N is what? N is 5M prime. So 85 times 2M prime plus 66 times, sorry, here 5N prime. 66 5N prime. Now, we can write it as 170M prime plus 33N prime. So we can factor from 10, 17M prime plus 33N prime. So we want that it should be multiple of 100 because 10 times this should be multiple of 100, the problem says. Because each pound is 100 pence. So 100 divides this, 10 times 70M prime plus 33N prime. We can divide both sides by 10. Why? Because when AB divides AC, you can conclude they are equivalent, that B divides C. So we can conclude 10 divides 17M prime plus 33N prime. So the smallest possible case we want at M plus 2M. Let's see. M plus N is what? M plus N is 2M prime plus 5N prime. We want that this one be minimum. So if both of them be 1, it will be okay. Okay, so for 7, our answer is 7 or better than that. Okay, now, when both of them 1, we reach 7. Okay, M prime, N prime. Then M and N will be 2, 5. So if you want to reach a better answer than 7, M prime, N prime are at least 0. It should be 0, and the other one. Here, 10 divides this, so N prime should be multiple of 10. It will be greater, because 5N prime 50. If this one is 0, this one should be 10, it will be 20. Both of them are worse than 7, so the answer we proved is at least 7, because we don't have any possible case. So it is choice C. Let's work on next problem, but before that, I told you idea 5. Let me tell you homework 5. Homework, it was what? Homework 3, homework 4. You can let me tell you a problem from AMC. Look, AMC and BMO are the most prestigious next national exams in Olympiad. So if you solve problems, the ideas are similar. AMC, okay, problem 23 is from AMC 12B 2022. You can do this one as homework, and then you learn how to work with modulo. It's so much useful. Also, we had this problem in AMC 10. It's a common problem. So if you want to learn how to work with identities, how to work with modulo, how to work with divisibilities, improve your number theory, and learn for I can say for number theory 20, 30 important tricks and ideas. As I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let's write AMC 12B 2022. Problem number problem number 23. Okay, so here how many ideas? 5 ideas and 4 homeworks. Okay. Problem 7 we've solved. Problem 8. In the diagram, the outer hexagon is regular and has area of 216. What is the shaded area? Okay. Okay, next idea here. How many ideas did we have? I5, I6. So in I6, all things about regular hexagon. Angles and all lengths, all diagonals, all sides, area, all properties. I7, a regular octagon. These two figures are famous. Octagon. Again, all angles here, octagon. In terms of length, all length in terms of length of side, length, area of octagon. There are some approaches, so you should learn them. Here, we will work on only the things we need in regular hexagon. I will tell you something about that. And if you want to learn also regular octagon related problem in AMC, as I said before, feel free to send message to my WhatsApp number in the description comments. Now let's focus on this one. It says the diagram, the outer hexagon is regular and has area 216. We know if you have a regular hexagon, we can connect all these things. Then angle of regular hexagon is what? Is 180 times 6 minus 2 over 6. It is the formula for n minus 2. So we divide 30 times 4, 120. And then because it's 120, it is 60, it is 60. Because 60, 60, 60, all of them are equilateral triangles. Okay, all of them are equilateral triangles. Now, if you want to calculate area, it will be 6 times area of, let me write it. Suppose the side length is A, 6 times each of them is an equilateral triangle with side length 1. It will be 6 times A squared root 3 over 4, which is 3A squared root 3 over 2. Okay. Now the problem says it is what? 216. So we can find A is what? So let's check. 3, this one, it will be 7, 2. 2 times 7, 144. So A squared root 3 is 144. Okay. Now, A squared is 144 over root 3. Okay, we have this. Now, let's focus on this area. Let's see. Okay, we've considered is A, the side length. I want to calculate the shaded region in terms of A. Let's use a bit angle chasing. We proved that each angle is 120 because it is isosceles triangle. So this one is 180. Let me write 180 minus 120 over 2. It will be 60 over 230. So this angle is 30. This angle is 30. Similarly, this angle is 30. All of them. This angle similarly 30. So it is 120 minus 30 minus 30. It will be 60. Similarly, it is 60. It is 60. So we have what? We have a equilateral. Let me maximize it. Okay. Okay. We have this part, this part, this part, equilateral triangle. And we should subtract these 3 corners. So the angles are what? 30, 30 similarly. So 30, 30, this one will be 120, this is 60. So we should subtract these 3 equilateral triangles. First, we should find these length. How can we find? We can draw a perpendicular, or I can draw the rectangle, the triangle. It is 30 and Somehow we can say isosceles triangle 30 30. It is A, it is A. We want to find third side. So if you draw perpendicular, it is 60. And A opposite to 60 is A root 3 over 2. This one is also A root 3 over 2. These are the properties that I said in I6 we should consider all lengths, all diagonals. If we calculate this length, it will be A root 3. Okay, so let me consider this one as ABC. Side of ABC is A root 3. So area of ABC is what? Is A root 3 squared root 3 over 4. So it will be 3A squared root 3 over 4. Now we want to subtract ADE. Okay. So if we want to find this, we know this part is root 3 similarly. We should subtract these two lengths. Now, if we want to subtract these two lengths, let's see, how can we do this? So, this part, again, we draw perpendicular, we draw altitudes. It is 30, 30, 30, 30. Isosceles triangle, this length is A, so this one is A over 2. This one is 60, and we want to find this length. So, if it is X, this one is X, this one is X, this one is A, it's A root 3 minus 2x. How can we calculate X? X root 3 over 2 opposite to 60 is A over 2. Okay, 2 will be cancelled. X equals A over root 3. Okay, now D is what? Is whole length, which we've calculated is A root 3 minus DE. Look, I could tell you easier solution, but I want to show you how we can do angle chasing, how we can find lengths. Okay, we don't want to reach only the solution because in some other problems, maybe we need to solve a harder part. So we want to analyze a figure. When you see a figure, it's good to write angles, angle chasing, write lengths. So DE is A root 3 minus 2x, which is A root 3 minus here. We can write it as A root 3 over 3. Multiply both numerator and denominator by 3. Minus 2A root 3 over 3. If you use common denominator, it will be 3 times this minus this, A root 3 over 3. So we will understand all of them are equal. Okay? We could prove it. That's why these lengths are equal. So A over root 3, A over root 3, A over root 3. Now, so the area of shaded region is what? Is area of ABC minus 3 times area of each triangle. Side of them is what? A root 3 over 3. So you say A root 3 over 3 squared over root 3 over 4. So area of ABC was what? 3A squared root 3 over 4. Here minus 3 over 4 times A squared over 3 times root 3. Okay, so now we can do what? We can cancel the 3 and 3. We can factor from A squared over 4. It will be 3 root 3 minus root 3, which will be 2 root 3. It will be A squared over 4 times 2 root 3. 2 and 4 will be cancelled, so it will be A squared times root 3 over 2. We've calculated A squared is what? Is 144 over root 3. So it will be 144 over root 3 times root 3 over 2. And we can cancel, it will be 72. Let's see the choices. Choice E is 72. Okay, so the answer is choice E. I told you two ideas. Let me tell you homework about them. Homework 4, homework 5. Problem from AMC 2022. Okay. Okay, this problem from AMC 12B 2022. It is related to regular hexagon, and you can try this. AMC 12B 2022, last problem. Problem 25. You can do this one as homework. Okay, another homework that again related to those things is this problem 21 from AMC 10A. It can be useful. Okay, homework 6, AMC 10A 2022, problem 21. You can do these two homeworks, and also we have some problems harder than this in AME and other exams. In BMO, if you want to learn important ideas like these, 7 ideas, and also want to solve more problems as homework, feel free to send message to my WhatsApp number in the description and comments. It was problem 8. Let's try problem 9. Problem 9, a light nanosecond is the distance that a photon can travel at the speed of light in 1/billionth of a second. The speed of light is 3 times 10 to the 8 meters per second. How far is a light nanosecond? For this problem, the only thing that you should know is 1/billionth is 10 to the negative 9. So it says 1/billionth 10 to the negative 9 of a second. Okay, speed of light in 1/billionth of a second. So speed of that is 3 times 10 to the 8. So meters per second squared, here seconds. So when you multiply, the unit will be meters because uh, because after production meters will be left. So let's see. It will be 3 times 10 to the negative 9. We know that a to the m times a to the n equals a to the m plus n. 10 to the 8 minus 9 plus negative 9, which is 10 to the negative 1 meter. So it will be 0.3 meter. As you can see, we don't have, so this choice will be rejected, meter, meter. These two choices are centimeter. If you want to change meter to centimeter, each meter equals 100 centimeters. Okay, so it will be 30 centimeters. So the answer is choice B. Okay, this problem was easy, so let's solve the next problem. Problem 10. What is the value of x in the equation this equals 3? For this problem, first we cross multiply, and we should pay attention at the end our answer. For example, if you find x1 negative 1, the denominator shouldn't be 0. At the end, we will check. Okay, if we cross multiply this times 3 times this equals this times, it's 3 over 1 times 1. So 1 plus 2x, this times 1, 1 plus 2x plus 3x squared equals what? 3 times this. 3 times 3 is 9. 3 times 2x, 6x plus 3x squared. Okay? We subtract 3x squared from both sides. And then we take 2x to right side, 9 to left side. So we can say 1 minus 9 equals 6x minus 2x, which is 4x. 1 minus 9 is negative 8. Negative 8 equals 4x, so x equals negative 2. Now let's check negative 2 in the denominator. 3 plus 2 times negative 2 plus negative 2 squared. It will be 3 minus 4 plus 4. It will be 3. So the denominator is not 0, and x equal negative 2 works. So the answer is D. It was problem 10. Let's try problem 11. In the number triangle shown, each disk is to be filled with a positive integer. Each disk in the top or middle row contains the number which is the product of the two numbers immediately below. What is the value of n? Okay, so let's consider here we have n, and here, for example, we have a, here we have b. This part is what? This part is an, this part is what is bn, and because the problem says this one is product of this and this a and bn, and 2022 is an times bn. Okay, so it is equal to abn squared. Now abn, all of them, the problem says, are positive integer. So a, b, and n are positive integers. So now let's try to factorize 2022, because we should write it as ab times n squared. It's 2 times 10, 11. 10, 11 is multiple of 3. So it will be 3 times 3, 3, 7. If we check, we will see that 337 is not doesn't, it's a prime, let's say, like so. How, when you want to check is it prime or not, we should check divisibility up to square root of that by prime numbers. It is not multiple of 2. For 3, it is not multiple of 3. Some of the digits is not multiple of 3. For 5, last digit is 7, not multiple of 5. 7, 4 times 7, 28. 57, the remainder is 1 when divided by 7. 11, 33, the remainder is 7. Next one, 13. If we divide by 13, 2 times 13, 26. 4, 3, 7. 77 is not multiple of 13, 15, 17. 1 times 7, 17, then 167. The remainder is -3 or 14. Next one, 19. We don't need to check division by 19. Why? Because 19 squared is 361. So square root of 337 is less than 19. So you should check up to square root of that number. It is not multiple, so the prime factorization is 2 times 3 times 337. And it is equal to abn squared. So look here, we don't have any squared here. So the only, and we know n is a positive integer. The only possible case for n is what? To look, for example, if n is 2, then here we should have 2 squared. Or if n is 3, we should have 3 squared. So the only possible case for n is n equals 1 when n is positive integer, and the answer is A. So let's try next problem, problem 12. What is the sum of the digits of the integer which is equal to 1, 2, 3, 4, 5, 6, 7 sixes squared minus 1, 2, 3, 4, 5, 6, 7, 7 threes squared? Okay, here we should use the famous identity, which is x squared minus y squared is x minus y, or x plus y times x minus y. Now here we have 1, 2, 3, 4, 5, 6, 7 squared minus 1, 2, 3, 4, 5, 6, 7 squared. If we use this formula, it will be this 6 plus 3, 9, 1, 2, 3, 4, 6, 7 squared times subtraction of them, which is 1, 2, 3, 4. I'm sorry, not squared. X plus y times x minus y, 1, 2, 3, 4, 5, 6, 7. Okay, now we have a formula, or sometimes we have, for example, dot, dot, dot. For example, 999, n9s, or n3, something like this. We can write it as 10 to the power of what minus what? 10 to the power of n minus 1. So we can write it as 10 to the power of 7 minus 1 times 1, 2, 3, 4, 5, 6, 7. This idea, we call it star. That you use this was useful also in a problem in Promise. It is a summer camp, prestigious summer camp USA, for example, like SUMEC, that is for Stanford. This is another summer camp for Boston University. I will tell you one of the problems as homework. And okay, we call it which idea? Let me see the number of idea and homework. Homework 5, homework 6, so it will be homework 7 and I7. Okay, I7, homework 7. So here we can call it I8 and homework 8. Okay, at the end of the solution, I will tell you. It will be what? 10 to the 7. Let's expand. It is 3, 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 minus 1 times this, which is 1, 2, 3, 4, 5, 6, 7. Okay. Let's write these numbers on top of each other. It will be 1, 2, 3, 4, 5, 6, 7 times 10 to the 7, which is 7 zeros, 3, 4, 5, 6, 7, minus 7 threes, 1, 2, 3, 4, 5, 6, 7. Okay. Now, if we take, for example, 2 from left side. If we take 1 here, it will be 10, 9, 9, 9, 9, 9, 9, 10. 10 minus 3, 7, 9 minus 3, 6, 6, 6, 6, 6, 6, 2, 1, 2, 3, 4, 5, 6, 6 threes, 1, 2, 3. Let me write on top of the number. 1, 2, 3, 4, 5, 6. Okay, it is our number, and we should calculate. The problem says what is sum of the digits of this number. Okay, if we add, we have 1, 2, 3, 4, 5, 6 threes, 6 times 3, plus 2, plus 1, so here 2, 1, 2, 3, 4, 5, 6, 6 times 6, plus 7. Okay. 6 times 3 plus 6 times 6, if you factor from 6, it will be 3 plus 6. 2 plus 7 is 9. 3 plus 6 is 9. 6 times 9 plus 9. If you factor from 9, it will be 6 plus 1. So it is 9 times 7, which is equal to 63. Let's see the choices. Okay. So here the answer is choice E. Now let me tell you homework 8 is what? Promise 2022, and the problem is this first problem. Again, when you, for example, continue for n, it says generalization. Then, for example, we have n threes, okay? Then when we have m threes, it is 10 to the n minus 1 over 9 times 3. You can write it like this, okay? So it is exactly like the idea I've told you, and you can prove it. This is harder than this, but the idea is same. So this one is the next page. So we have I8 and homework 8. Okay. Let's try next problem. It was problem 11, problem 12. Oh, sorry. It was problem 12. Let's try problem 13. Three rugs have a combined area of 90 meters squared. When they are laid down to cover completely a floor of area 60 meters squared, the area which is covered by exactly 2 layers of rock is 12 meters squared. What is the area of floor covered by exactly 3 layers of rock? Okay, so let's consider we have 3 rocks. For example, the area of them, the figure is not important, only the area of them is ABC. From the first condition, it's 90 meters squared. A plus B plus C is 90. When they're laid down to cover completely a floor of area 60 meters squared. So now, for example, we want to completely figure this part, and Now it says the area. So some part is, for example, with one of them covered some parts. Two of them, three of them. Without loss of generality, suppose we have these things. So let's consider this A1, this area 2, A3. Then it says area of this floor is 60. So A1 plus A2 plus A3 is 60. And we know A1 is covered by only one of them. A2 is two of them, 2A2 plus 3A3. In this part, can you tell me it is equal to what? Pause the video and try first on your own. When you say A1, here covered with only one rug. A2, we multiply by 2. 2 rugs. So here, because it's covered with 2 rugs, we multiply by 2 and 3. So we've calculated area of each rug once. Here we multiply by 2 because we have 2 rugs. So we calculated each rug once. So plus 3A3 is 90 because of this part. Okay. Now let's move this part here. Okay. If we call it double counting, okay, I9 double counting or changing viewing angle. We can solve hard problem with this idea. I will tell you some problems as homework, changing viewing angle. So let's try A1 plus 2A2 plus 3A3 equal to 90. And then it says the area which is covered by exactly 2 layers of rock is 12 meters squared. So A2 is 12 meters squared. What is the area of floor covered by exactly 3 layers of rock? So A3 is what the problem wants, A3. Here we consider these 3 equations. We have A2, so let's replace A2. A1 plus 12, we plug in A2 with 12 plus A3 is 60. A1 plus 2 times 12, which is 24, plus 3A3 equals 90. Now, if we subtract 12 from first equation, it will be A1 plus A3 equals 60 minus 12, which is 48. And this one, A1 plus 3A3 equals 90 minus 24, 70, 66. Okay, so we have these two things. Now we want to find A3. So we can do what to these equations? We can subtract. 3A3 minus A3 to A3, A1 and A1 will be cancelled. 66 minus 48, it's 2, 12, and 18. So A3 equals 9. Okay. So it will be choice C and 9 meters squared. Let me tell you homework in previous part, homework 8, homework 9. It is what? We have, for example, some subsets, A, B, C. Or let's solve first A, B from 1 to 10. How many A, B are there? That's part A. How many A, B are there such that A is subset of B, part B, A intersect B is null set. Let's consider this set equals, for example, C. Part C, A union B is C. The number of elements in A union B or A intersect B equals 3. And part E, calculate sigma of A number of elements in A union B for all possible cases of that. F, calculate for all AB number of elements in A intersect B. Part F is easier, so try to solve part F first, then E. It is for 2 subsets. We have also 3 subsets, and so on. Let me tell you one more homework from Amy, the next round of AMC. Okay, it will be homework what? Homework 10. It is an Amy problem. Okay, it is Amy 1, 2022. Okay, so try this one as homework. For this one, you should also know van der Monde's identity. Let me tell you this one as idea 10. Suppose we have m boys and girls, and suppose you want to select k of them. Okay, so we can say all k from boys, 0 here, or k minus 1 boys, 1 girl, or k minus 2 boys, 2 girls, 2, 0 boy, k girls. Can you say it is equal to what choose what? It is equal to m plus n choose k, because from all of them we want to select k. And as a result, let's go with homework 11. At first solve homework 11, then homework 10, because you need this. N choose 0 squared plus n choose 1 squared. With van der Monde's identity, you can prove it. There are some important identities, ideas. If you want to learn them, feel free to send a message to my WhatsApp number in the description and comments. N choose 2 squared to n choose n squared equals 2n choose n. Okay. Now it is homework 11, homework 10. And how many ideas do we have? 10 ideas, 11 homeworks. Okay. Let's solve next problem, problem 14. The diagram shows a square KLMN. A second square PQRS is drawn inside it. PQRS as shown in the diagram, where P divides the side KL in the ratio 1/2. Okay, so let's write it. A new page. So here it says P divides KL. So it is X, it is 2X. And similarly, a third square PUVW is drawn inside PQRF as with T dividing PQ in ratio 1/2. So it is Y, it is 2Y. What fraction of the area KLMN is shaded? Okay, in this part, we use congruent triangles. How? It is X. We know, for example, this angle is alpha. Okay, it is 90. So this angle is what? 180 minus 90 minus alpha is 90 minus alpha. So we can conclude this angle is alpha. Again, it is 90. It is 90 minus alpha. This angle is alpha. 90, 90 minus alpha. This angle is alpha. Okay. Now, if you see this triangle, it is X. It is alpha. 2 alpha. Their hypotenuse equals. Okay. So we can say because PS equal PQ and this angle equal this angle by hypotenuse and a side, or you can say two angles and side between. We can conclude triangle KPK. KPS is congruent to triangle PLQ, is congruent to triangle QMR, is congruent to triangle NSR. Okay, all these four triangles are congruent. Now let me maximize the figure. Okay, so we said this triangle, this one, this one, this one are congruent. Now we can say what? We can say because they are congruent, it is x. So this one is x, and for example, it is 2x, this one is 2x. Okay. So here, we want to find what? Pay attention to the sentence of the problem. It says what fraction of area of KLMN is shaded. So area of KLMN is what? Is side squared, 3x squared. So if we want to find, we should find this area. For example, suppose this area, we should find this side, it is z squared. So if you find z in terms of x, the problem will be solved. At first, we should find y in terms of x, then z in terms of y, and z in terms of x. Okay, so here, as you can see, 2x and x, if we write Pythagorean theorem, we can say 3y squared equals, by Pythagorean theorem, 2x squared plus x squared. So we can conclude 3y squared is 9y squared, 2x squared is 4x squared plus x squared equals 5x squared. And then we can find y in terms of x. So y squared equals 5x squared over 9. So if you take square root, y equals x root 5 over 3. So let's call this one 1. Now it is z. Again, like this part, we can say this triangle, this triangle, this triangle, this triangle by the same method. Similarly, are congruent. So when it is 2y, it is 2y. So here we can say z squared, again by Pythagorean theorem, is z squared is 2y squared plus y squared. Y squared plus 2y squared equals to y squared plus 4y squared equals 5y squared. So z equals, if you take square root, y root 5. Instead of y, we can write x root 5 over 3. Over 3 times root 5. So it will be 5x over 3. So it will be 5x over 3 squared over 3x whole squared equals 20x squared. X squared will be cancelled. It will be 25 over 9 times 9, 81. Okay, this area, and it will be choice A. Okay, finding ratio of area is useful. We have also some similar problems. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. It was problem 14, problem 15. It says what? Okay, problem 15, the hare and the tortoise had a race over 100 meters in which both maintained constant speeds. When the hare reached the finish line, it was 75 meters in front of the tortoise. The hare immediately turned around and ran back towards the start line. How far from the finish line did the hare and the tortoise meet? Okay, let's draw to understand it completely. We know the distance is 100 meter, and constant speed when the hare reached the finish line. So tortoise 75 meters in front of tortoise, 25 t, and the hare is here. The hare immediately turned around and ran back towards the start line. How far from the finish line did the hare and tortoise meet? So goes here and then hare reaches here. So we want to see how far from the finish line did the hare and tortoise swim? It is finish line. It is starting line. Okay. And here, start line. So it is x. We want to find this x. It is 25. So 100 minus 25 minus x, 75 minus x. Okay. And now we have a formula, important formula, that the speed equals d over t. Okay. We can use it when in this part that tortoise reaches here and hare reaches here, their times equal. Okay, time equals what? Distance over b. So here, t of t, time of t, when they reach this part equals time of hare. The distance of tortoise is 25 over v of tortoise equals 100 over speed of hair. So if we multiply both sides by 1 over 25, it will be 4. So we can conclude speed of H equals 4 times the speed of tortoise. Okay, now here we know again it starts from here, it starts from here. Again, their new time equal. So their new time, let's call it T prime T equals T prime H. When tortoise start from here and hair starts from here. They reach here, so their times equal. Now, the distance for tortoise is 75 minus x over speed of tortoise equals x over speed of hair. We know speed of hair, we've proved, is 4 times speed of tortoise. 4 times vt. Then you can multiply both sides by vt. Then you can multiply both sides by 4 or cross multiply. If we multiply both sides here and here by 4, left hand side is 4 times 75, 300, minus 4x equals 4 times this part is x. So we can take negative 4x to right side. It will be 4x plus x, 5x. Now we can divide both sides by 5. It will be 60. Okay. Now we will see the answer is choice B. Okay. Here, for all these problems, you should use this formula. Let's see. We can call it which idea? I10, I11. And we have some problems in AMC 10 and other AMCs you can solve. Okay, if you wanted to know other homeworks, feel free to send message to my WhatsApp number in the description comments. Because I should search and it takes time, so we can work on that if in future. So we solved problem 15. Now let's work on problem 16. Which diagram could be a sketch of the curve square root of x plus square root of y equals 1? Okay, let's see. Square root of x plus square root of y. It is not a line, obviously. It doesn't pass through 0, 0 because 0 plus 0 is 0. It is not 1. Here it is also not a line. Let's see which of them. Let's pay attention to y-intercept, x-intercept. If x equals 0, then square root of y is 1. Y is 1. If y equals 0, then x is 1. So we can conclude it is 1, 1. It is 1, 1. It is 1, 1. It is 1, 1. Okay. So now we want to find a point. We want to see it is below that or on top of that. If we pay attention to this line, for example, middle, it is 1 half and 1 half. So let's see, for example, x is 1 half, y will be what? Okay, and because it is the square root of x plus square root of y equals 1, we know 1 half plus 1 half equals 1. So under what case root x is 1 half, x and y should be 1/4 and 1/4. Okay, so it will be what? It will be some point here. Okay, 1/4, 1/4. So it passes through this part. Now, can you tell me which choice is correct? Because it should be something like this. We can reject it. We can reject it. Okay, so the correct answer is B. Okay. So here replacement was useful, finding important point x-intercept, y-intercept on the graph. We write it as I11, I12, xy intercepts, and finding important points sometimes, if you learn derivative, can be useful, but you don't need turning points or what? The graphs, for example, quadratic equations. It opens up under what condition, opens down, in how many cases it has two roots. You should know delta here. Sometimes we need to know, for example, foci of ellipse. If you want to learn these ideas, we have some variables. Sometimes we need to work on circles. Lots of things in coordinate geometry. Coordinate geometry. If you want to learn them, If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. So let me write some more and leave a homework from AMC. If you have a line, then ax plus by plus c equals 0. If you have a plane, you can write ax plus by plus cz or cz plus d equals 0. Sometimes we have a point, and we want to find the distance from this point. It has a formula. Sometimes you have a plane, and from that plane you want to find the distance. You have some formulas, let me write them. Okay, in this case, the distance, for example, suppose it is x0, y0, and it is equation of line like this, so it will be absolute value of ax0 plus by0 plus plus c over square root of a squared plus b squared. If the equation of the line is this, and our point is x0, y0. Here, in 3D, maybe coordinate of point is this, coordinates, and the equation of plane is this. The distance here is ax0 plus by0 plus cz0 plus d absolute value over square root of a squared plus b squared plus c squared. Okay, now you can solve a problem from AMC. This problem from AMC. It was, I'm sure it was in AMC 10, but maybe in common with also AMC 12. And the year I remember it was for 2021, around that year. Okay, you can try this problem as which homework? Let's see, we had 12 ideas. And last homework was homework 11, homework 12. Okay, you can try this problem. Let's continue. It was problem 16, coordinate geometry. Problem 17. The shape shown is made by removing four equilateral triangles with side length 1 from a regular octagon with side length 1. Okay? So 1, 2, 3, 4. What is the area of the shape? Okay, let's complete it again. 8 sides. Okay, and one important thing you should know, I think I told you here, some properties in regular octagon you should know. Here we need areas, okay? In each problem we need some of them, and as you can see, so much is fluent. Senior UKMT. We only work the things that we need here, but there are lots of things maybe in the upcoming SMC you need them. Here we need area in octagon. Let me tell you a trick to calculate that. You continue this part. Let me write it with other color. Let's draw it with green. Here, here. We continue like this. We continue like this one. We continue like this. Okay. Now, at first, we want to calculate angle of this octagon. 180 times 8 minus 2. The formula is this, over 8. So 8 minus 2 is 6. And if you divide this one by 4, 45, this one by 2, 3, it's 135. So this angle is 45. Similarly, this angle is 45. What do we know about octagon side length? 1. So it is 1, it is 1, it is 1, it is 45. So sine 45 is root 2 over 2. This one also is root 2 over 2. Similarly, it's root 2 over 2. Now, the area of octagon, let's call this one A, B, C, D, E, F, G, H. So it is a lesson. The area of A, B, C, D, E, F, G, H equals what? Equals the whole square. The side length is what? 1 plus root 2 over 2 plus root 2 over 2, which is 1 plus root 2, because 2 times root 2 over 2 is root 2, squared minus 4 times area of the corners. Area of this corner is what? Is root 2 over 2 times root 2 over 2 all over 2. Okay, and it will be what? 1 plus root 2 squared is 1 plus 2 root 2. 4 here will be cancelled. Root 2 times root 2 is 2 over 2, 1. Minus 1. It will be cancelled. So it will be 2 plus 2 root 2. The area of octagon. Now, here we should cancel or we should remove how many triangles find shaded region? 1, 2, 3, 4. 4 equilateral triangles, the problem says. If we have an equilateral triangle with side length a, the area is a squared root 3 over 4. So the answer is 2 plus 2 root 2 minus 4 times side length is 1, a is 1, root 3 over 4. So we cancel this, it will be 2 plus 2 root 2 minus root 3. So we choose 2 plus root 2 minus root 3. The answer is choice B. Okay, we've analyzed this problem, the idea I told you before, and also this problem can be useful because it's regular hexagon. For previous part also you can solve those problems in previous problem that we worked on hexagon, octagon. Okay, it was problem 17. Let's try next problem. Problem 18. The numbers x and y are such that 3 to the x plus 3 to the y plus 1 equals 5 root 3 and 3 to the x plus 1 plus 3 to the y equals 3 root 3. What is the value of 3 to the x plus 3 to the y? Okay, here we want to use power rule. The first equation is what? 3 to the x plus 3 to the y plus 1. We know a to the m plus 1 equals a to the m times a to the n. So we can say, for example, 3 to the y plus 1 equals 3 to the y times 3 to the 1. So we can write first one as 3 to the x plus 3 times 3 to the y equals 5 root 3. And next one is 3 to the x times, or let's write 3 times 3 to the x, again by power rule, because it is x plus 1, plus 3 to the y equals 3 root 3. Now, if we add these two equations, 3 times 3 root x plus 1 times 3 to the x is 4 times 3 to the x. Plus, next one, 3 times 3 to the y plus 1 times 3 to the y is 4 times 3 to the y equals 5 root 3 plus 3 root 3 is 8 root 3. Now we divide both sides by 4, so 3 to the x plus 3 to the y equals 2 root 3. Okay, so when we have similar equations, it's good to add or subtract with respect to the things that the problem wants. So the answer is 2 root 3. The answer is choice B. Okay, let's try other problems. Problem 19. Okay, so how many pairs of real numbers x, y satisfy the simultaneous equations? X squared minus y 2022 and y squared minus x equals 2022. Okay, let's try. So let's write equations on top of each other. X squared minus y 2022, y squared minus x equals 2022. When we see similar equations, it's good to subtract. Let me check it is which idea. Homework 12 and idea 12. Okay, so idea 13, and I will tell you homework at the end. I13, when you see similar equations, and I will tell you a problem as homework 13, a problem from Amy. At the end of the solution, I will tell you. So the idea is what? One of the most important idea when you see similar equations, you should subtract. So x squared minus y squared minus y plus x, 2022 minus 2022, 0. Now we have a famous factorizing. X squared minus y squared is x minus y times x plus y. Here we can subtract, we can write it as minus, or let's write plus x minus y, okay, equals 0. Now we can factor from x minus y, it will be x minus y times x plus y plus 1 equals 0. So we have two cases. The first one is 0 or second one 0. X minus y equals 0. Or second case, x plus y plus 1 equals 0. When x minus y equals 0, then y equals x, and we can replace in one of them. It will be x squared minus x equals 2022. The problem says x, y are what? Are real numbers, okay? So here is the quadratic equation, x squared minus x minus 2022 equals 0. And let me write quadratic equation is what? When we have ax squared plus bx plus c equals 0, then x equals negative b plus minus square root of b squared minus 4ac over 2a. So here x will be negative 1 plus minus square root of negative 1 squared minus 4 times a times negative 2022 all over 2a. So it will be 1. Let me write below that. It's 1 plus minus square root of 1 plus 88 over 2 equals this. So it will be 1 plus minus square root of 89 over 2. Two real solutions. Now let's check next one. Here x plus y plus 1 equals 0. So y equals x minus 1. Okay, we can replace in one of them. For example, x squared minus y, which is minus x plus 1 equals 2022. So x squared minus x minus 2021 equals 0. So here again, if we use quadratic equation, will be x equals negative 1 plus minus square root of, if we use this, b squared 1 minus 4 times this 4 times this is 84. It will be plus over 2. So it will be 1 plus minus square root of 85 over 2. So we found two more answers, two answers here, four answers. So it will be what? It will be choice A. Now, let me tell you homework 13. The problem of Amy is what? Homework 13. Okay, it is Amy 2 2023. Last Amy. Problem 4. As you can see, we have similar equations here. We can try this one as homework. So let me write it here. Amy 2 2023. Problem number 4. In that problem, again, we have similar equations. We can solve this as homework. And idea 13. Okay. If you wanted to learn more ideas or wanted to solve more problems, more related homeworks, feel free to send message my WhatsApp number in the description comments. Okay, it was problem 19. Let's try problem 20. A square is inscribed inside a quadrant of a circle. The circle has radius 10. What's the area of this? Okay, we know this square is inscribed in this quadrant of a circle. The circle has radius 10. Okay. Here we can connect this part and this part. Why we connect? Because both of them are radius. So this radius is 10, this radius is 10. We want to find what's the area of the square. So suppose the length of this square is a, so the answer is a squared. Should calculate a squared is what? Here. We want to find a. This angle is what is 45. Why? Because of symmetry, this is equal to this one. This part equals this part is 90, so this one is 45. This one is 90. And this radius is what? This radius is 10, we've written. This is a because side of square. We want to find this length. Here this length is a, and here it is 45, so sine 45, root 2 over 2. So it will be a root 2 over 2. Now let me call this one OAB. In triangle OAB, we want to use cosine law. Cosine law is what? In triangle ABC, a squared equals b squared plus c squared minus 2bc cosine a. Let's call this one as which idea? Idea 13, idea 14, cosine law, sine law, double Pythagorean theorem, double Pythagorean theorem, and ratio lemma. These ideas are so much useful. So if you want to work on all of them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let's use cosine law in triangle OAB. So it will be what? 10 squared equals a squared. So in this triangle, 10 squared equals a squared plus a root 2 over 2 squared minus 2 times a root 2 over 2 cosine of this angle, cosine 135. Now we can find a by this action. So let's calculate 100 equals a squared plus 2a squared over 4, which is a squared over 2. These two will be cancelled. Cosine 135 is negative root 2 over 2. Negative, negative will be plus. Root 2 times root 2 is 2. 2 over 2 here will be cancelled. It will be plus a squared. So it will be what? If we use common denominator, 2a squared plus 2a squared, 4a squared plus a squared, 5a squared. And, okay, if we divide both sides by 5, it will be 20 here. And now if we multiply both sides by 2, a squared is 2 times 20 is 40. So the answer is 40, which is choice D. Okay, I've told you this, the 14th idea. Let me tell you homework 14. At first, let me tell you double Pythagorean theorem is what. If we have something like this in AME also, it is useful. In AMC 2022 also useful. When we have this, look, the name is not so much famous. I've called it double Pythagorean theorem to remember when we want to use it. So we connect these things. It is A, it is B, it is C, it is D, it is P. Double Pythagorean theorem says PA squared plus PC squared equals PB squared plus PD squared. Let me check PA squared minus PB squared equals PD squared. Yes. So try to prove it as homework. Homework 14. So let me write homework 14. Try to prove it. It's easy. Now, this one, so will be homework 15. Homework 15 is AMC 12A 2022. Let me tell you which problem. Okay, it is problem 20 of AMC 12A 2022. Okay, problem 20. Problem 21, the perimeter of a logo is created from two vertical straight lines. Okay, these two vertical lines. Two vertical straight edges, two small semicircles, this one and this one, with horizontal diameters. Okay, yes, horizontal diameters, and two large semicircles, this one and this one. Let's read two large semicircles, both of the straight edges and the diameter of the small semicircles have length 2. The logo has rotational symmetry as shown. What's the shaded area? So let's calculate. So let's draw the lines that we need. Two small semicircles. We draw the diameter horizontal. Two large semicircle. Both of the straight edges and the diameters of small semicircles have length 2. So it is 2. It is 2. This length is 2. This length is 2. Rotational symmetry as shown. What is the shaded area? Okay. So if we want to find shaded area, we've drawn the, let me tell you, diameter of smaller circles. Now we want to draw diameter of larger circles. Let's draw them. Okay. Now in this part. So here, let's do something. Let's calculate this area on this part. This shaded region equals this shaded region. So I will calculate only one of them and then multiply by 2. If you see here, it is semicircle. Here, it is a triangle. We add these two things and subtract this semicircle. Okay, small semicircle. So this is what, at first we should find the radius of this semicircle. By Pythagorean theorem, it is 2, it is 2. So this length is the square root of 2 squared plus 2 squared. So it is the square root of 4 plus 4, which is the square root of 8, which is 2 root 2, okay? So this length is 2 root 2, this radius. So the semicircle, let me call this one area 1. Area 2, the triangle, and area 3, the semicircle. So the answer is area 1 plus this large semicircle. At first, we should multiply by 2 because here also we have same thing. Now here, A1, this area, plus area of this triangle, A2, we call it A2, minus area of this small semicircle, A3. Let's calculate 2A1. A1 is what? Is, let's call this radius big R, this radius small r. It will be pi r squared, big R squared, over 2. Plus A2 is 2 times 2, triangle, 2 times 2, over 2. Minus area of A3. It is pi small r squared over 2 because it's semicircle. Big R is what? We found that 2R is 2 root 2, so big R is root 2. Small r is what? Because the diameter is 2, it is 1. So when we multiply by 2, 2, 2, 2, 2 will be cancelled. Big R is root 2, so the first one is 2 pi plus 4 minus the small r is 1 minus pi. 2 pi minus pi is pi, pi plus 4. So the answer pi plus 4 is which choice? Is choice D. Okay. Okay, here that we have some circles, semicircles, calculating area. Let me tell you homework 16. Homework 16 is a problem from AMC. You can try this problem. And if you wanted in or wanted to solve more problems or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, we solved problem 21. Let's focus on problem 22. How many pairs of integers x5 satisfy the equation square root of x minus square root of x plus 23 equals 2 root 2 minus y? Okay, when we have square root, we have two approaches. Let me tell you up till which idea we had. I14, I15. When you have square root, we have two approaches. Raise to the power of 2 or use a variable, changing variable. Okay, these two ideas are so much useful. Now here, let's write the main equation. Square root of x minus square root of x plus 23 equals 2 root 2 minus y. Now here, if we raise both sides to the power of 2, it will be what? X minus square root of x plus 23. Let's use first approach. Equals the first one, and let's write 2 root 2 minus y whole squared. It's first one squared, which is 8, plus second one squared minus 2 times first one, times second one minus 4 times 2, square root of y. Okay, now again, here we have square root, but let's do something. Let's consider square root of x plus 23 in one side. So we can say, we can take x to other side, it will be negative square root of x plus 23 equals 8 plus y squared minus x minus 4 root 2y. Okay. Now, again, we raise both sides to the power of 2. Left side will be x plus 23. Right side, I call this one a, this one b. It is a squared, 8 plus y squared minus x squared plus this one squared, which is 16 times 2, 32y squared minus 2 times 8 plus y squared minus x times 4 root 2y. Okay, so as you can see, the problem says what? X and Y are integers. Okay, so we can conclude what? This number is integer, this number is integer because x, y integer. But here we have square root of 2. So here the coefficient should be 0. Because if the coefficient is not 0, then root 2 is this. You can take all things to one side. Is that integer over the coefficient here of root 2. And root 2 will be what? Will be a rational number. But we know root 2 is irrational number. Let me explain again here if you have question. Let's call this one, for example, C, D, E, and let's consider this part f root 2. Okay, the whole part, f root 2. I want to say f0. If f is not 0, you can write as c minus d minus e equals f root 2. So we can divide both sides by f over f is root 2. So it is integer over integer, so it is rational. We reach contradiction. So we conclude f is 0. So the coefficient here is 0. We can conclude. Coefficient is what? Is negative 2. 8 plus y squared minus x. It is f. That's right. F here, by the definition that we consider, is negative 2. 8 plus y squared minus x times 4y. It is equal to 0. Now we have two cases. The first case, y is 0. Second case, 8 plus y squared minus x is 0. Now let's consider both cases. And the problem was what? How many pairs of x integer xy satisfy this? Okay, if y is 0 here, we can cancel y. And we raise both sides to the power of 2. It will be x minus x plus 23 equals 2 root 2. So here, negative 8 plus 23 equals 2 root 2 minus x. Then we raise both sides to the power of 2. Let's see here. When y is 0, we've taken this to this side. Here, 4 root 2. 2 root 2 squared. Sorry. Here, I've made a mistake. So it is equal to square root of this number, okay? Now, if we raise to the power of 2, it will be x minus x plus 23 equals 8. Then we take x to right side, negative x plus 23 equals 8 minus x. So we raise both sides to the power of 2. Left side it will be x plus 23, right side will be 64, plus x squared minus 16x. Then, if you take all things to right side, it will be x squared minus 16x. We take x to right side minus 17x. 64 minus 23 is plus 41. Okay? Okay, if you have integer solution, you can factorize, but it's not possible. If you calculate delta or discriminant, if you want to use x, let's see. X is negative b, 17 plus minus square root of 17 squared is 289 minus 4 times 41, which is 164 over 2. So it will be 17 plus minus square root of 521 over 2. Square root of 125 is not perfect square. So in this case, we don't have any answer. Let's check second case. Because here we found real solutions. The problem says x and y are integers. 8 plus y squared minus x equals 0. Okay. Now again, here, let's work on main equation. In this case, 2 root 2 minus y equals that. And now we can do also something. Here, when this part is 0, we have this part. So let me copy. Okay, 8 plus y squared minus x is 0. So this part is 0. X plus 23. Look, what I done was this part is 0. So this part is, we have this equality. I've copied and pasted here. So this one 0, x plus 23 equals 32 y squared. Okay, so again, we know that from the equation here, y squared equals 8 minus 8. So if we replace x plus 23 equals 32 y squared. Instead of y squared, we write x minus 8. So it will be 32x minus 256. Okay, we have these two parts. So 23 plus 256 equals 32x minus x, 31x. So it is equal to 3 plus 6, 9, 2 plus 5, 7, 279. Okay, so if we divide both sides by 31, x equals 2, 9. And y equals what? Y squared, we said, is x minus 8. Is 9 minus 8 is 1. So y is plus minus 1. Let's check both of them in our equation. In first one, x is 9, y is plus 1. In next one, x is 9, y is negative 1. If we, let's replace it in main equation. Okay, main equation is what? It's this one. Always at the end, when you reach some solution, try to check, because maybe we had some careless mistakes. So here for first one, square root of, let's check, 9 minus 9 plus 23. We should see, is it equal to 2 root 2 minus 1? Now it is equivalent of this square root of 9 minus square root of 32, which is equal to 2 root 2 minus 1. 2 root 2 minus 1 is positive. So we can, and also this one positive, we can raise to the power of 2. 9 minus root 32. Root 32 is 4 root 2. Equals this squared, which is 8, plus this squared, which is 1, minus 2 times this. 2 times this one is minus 4 root 2, which is equal. So the first answer is okay. If y is negative 1, here it will be 9 minus 9 plus 23 equals 2 root 2 plus 1. Now, again, if we raise both sides to the power of 2, left side will be 9 minus 4 root 2. Right side will be 9 plus 4 root 2. So this one doesn't work. So we found one answer. Now let's check the choices. It is 1. So as you can see, this idea, 15, we've raised to the power of 2 and we've solved this problem. Okay, let me tell you a homework from this idea. It was homework 16, homework 17. Similar problem. X cubed plus 1 equals 2 times cube root of 2x minus 1. And calculate x is 1. Try this one with the idea I've told you. If you had question or wanted to learn more ideas, feel free to send message to my WhatsApp number in the description and comments. Okay, let's try problem 23. 3 squares GQOP, GQOP, this one. HJNO, HJNO, RKMN, RKMN. Okay, have vertices which sit on the sides of triangle FIL. Okay, the triangle FIL, yes, as shown. The squares have areas 10, 90, 40. These numbers 10, 90, 40. These numbers are the areas of these three squares. And it says, what is the area of triangle FIL? The whole figure. So let's try. Okay, one thing we can say here, we've solved also in other problem. We can use similar triangles. If we consider this angle, this point is, for example, alpha. This one is 90 minus point. Okay, this one is 90 minus this point. This 90. So this angle is 180 minus, because the whole part is 180 minus 90 minus this one. Again, this angle will be point. Similarly, because it's 90 minus point, this angle will be point. 90 minus point, this angle will be point. This angle 90 minus point, this angle will be point. Let me maximize the figure. And let's erase this part. Okay. Okay, now let's focus on this figure. When it is 40, the area is 40. The sides are the square root of 40. Okay. So here it is square root of 40. Here it is square root of 40. Here it is square root of 40. Here it is the square root of 40. And now this part is 190. So it is the square root of 90. So this length, the whole part square root of 90, here is square root of 40. So this length is the square root of 90 minus square root of 40. Okay. And on, because all of them have root 10, let's do something. And 90 is, let's write all of them in terms of root 10. Square root of 40 is 2 root 10. Here 2 root 10. 90 is the square root of 9 times square root of 90 is the square root of 9 times square root of 10, like square root of 40. That equals square root of 4 times square root of 10. Square root of 4 is 2, 2 root 10 by power rule. Here 3 root 10. So this part is 3 root 10. This part is 2 root 10 because of 40. The whole part 3 root 10 minus 2 root 10. Here we have root 10. Here we have 2 root 10. Let's write. One important thing is to use angle chasing in all problems of geometry, and the length that you can calculate. 3 root 10. We want to analyze the problem. Let's write all length. 3 root 10. Here, here is root 10. So the whole part is 3 root 10. Because it is 10, it is root 10. So why is it 3 root 10? Because of 90. So this length is 2 root 10, root 10, root 10, and 2 root 10. Okay. Now all these triangles are similar. So if we find one of them, we can find area of one of them. Then by considering ratios, we can calculate all areas. The problem, solution of the problem has been finished. We should work on only calculation. So it is root 10. It is 2 root 10. We want to see it is what? Root 10 squared plus 2 root 10 squared square root of. So it will be 10 plus 4 times 10. It will be 40, 50. It is square root of 50. Okay? So this length is a square root of 50. Now we've calculated ratios here. We have points root 10. Here 2 root 10. So it is twice this. So when it is 2 root 10, it will be what? 4 root 10. So we found this here. It is 3 root 10. So the ratio of this one, let me do something. Let me calculate area. Area of this triangle, okay? It is root 10 times 2 root 10 over 2, which is what? 2 over 2, 2 and 2 cancel, 10. This area is 10. Now, because the ratio of this one and this one is 2, so the area is 2 squared. Okay, if two triangles have the ratio k, two similar triangles, the sides, if the ratio of sides is k, the ratio of areas equals k squared. So because it is, look, it is 2 twice this, so the area is 4 times that, 2 squared. 4 times 10, 40. Now, here, it is 3 root 10. Here, because they are, we know it is 90 degree, because they are similar. One important point. One important point is that I is not necessarily 90. So let me erase this part. So let me erase this point. Okay, so we have 2 points here. If we use, it is 90 minus 2 points, it is 2 points. And this one is 2 points. So it is not necessarily 90 and it's not important. So we've calculated and this. Oh, sorry, this angle is not 2 points. Let me erase that. Okay, it is 2 points, 90 minus 2 points, 2 points. It is 90 minus 2 points. Okay, let's calculate other areas that we can calculate. It is 2 root 10, root 10. But here, as you can see, 2 root 10, root 10, uh, this triangle is congruent to this triangle, and point is opposite to 10. So from this part, we can conclude that it is 1 point, it is 1 point. Okay, now it will be okay. So here 2 root 10 times root 10 over 2. Like this one, the area is 10. If we want to calculate this part, here it is what? We don't have anything. It is 2 root 10. Here we don't have anything. It is root 10. So this one is twice this. So this one is half of this triangle. The area is 1/4. So 10 over 4. The area And because it is 1 point, this one is 90 minus 1 point. It is 90, and this one 90 minus 1 point, 90 again. This one also similar. Now, if we want to find the area, we say, okay, the area here is 10. Now let's calculate ratio. It is 3 root 10 hypotenuse over root 50 whole squared. So we've calculated all areas. Let's simplify this one. Root 10, 10 will be cancelled. It will be 10 times 9 over 5. 5, this will be cancelled. 2 times 9, 18. Okay, so 10 over 4 is 5 over 2. So if you write all areas, the answer, let's calculate the answer. 5 over 2, let's see the choices. Yes, we have something over 2 in some parts. Okay. 5 over 2, probably because we don't have any square, the answer is this, because we have only 1 over 2 here. So, but let's add all of them. 5 over 2 plus 10 plus 18 plus 10 plus 40. Now plus the squares, 10, 90, 40 plus 10 plus 90 plus 40. Okay. So if you add 90, 140, 10 plus 40, 50, 10 plus 18, 28. So it will be 5 over 2 plus 28 plus 50, 78. 78 plus 140. It will be 218. This one is what? 2.5. It will be 220.5. Okay, because we had only one area that has 0.5. All others are very integers, so only one choice we had that has something 0.5. So 220.5. We have lots of other problems similar to this. If you want to work on some of them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let me tell you one homework. Homework number what that can be solved with a similar problem. We can call this one let me tell you. It is so much useful, I-16, that when we have something like this, that we have 90, and then again another 90, another one, that these two triangles are similar. Okay, this one I-16 and let's solve one problem let's write one problem as homework. Homework 18, AMC 12B, last AMC 2022, the most prestigious National Olympiad exam. Problem number, it is this problem 13. Again, look, you can find similar triangles like that problem. Problem 13, AMC 12B 2022. Problem 13. Okay. Now it was 23, problem 23. Two problems are left. Problem 24. The numbers x, y, p, and q are all integers. X and y are variable, and p and q are constant and positive. The four integers are related by the equation xy equals px plus qy. When y takes its maximum possible value, which expression is equal to y minus x? Okay, here we have an idea. Let me tell you the name of idea is what we have: idea 16, idea 17. We call it SFFT and GSFFT. SFFT is a bit famous. We call it Simon's favorite factoring trick. Let me tell you it is what. For example, suppose we want to solve one problem from SFFT, one problem from GSFFT. The first one is xy, for example, equals 2x plus 3y plus, for example, 2. Then we write it as xy minus, so we want to find what? X and y, and x and y are integers. So let me tell you how you can prove it. You take 2x, 3y to left hand side, it will be negative 2x, negative 3y equals 2. Then we factorize. it will be x minus what or y? X minus 3 to create 3y minus 2. Negative 3 times negative 6 plus 2 8. Then we can write all cases 1 8 2 4 and 8 1 4 2 negative 1 negative 8 because they are integers. We should write all cases negative 2 negative 4 negative 8 negative 1 negative 4 negative 2. Okay. And here, for example, first one, you say x is what? X is negative 3. You take it to this side. X minus 3 is 1, so x is 4. And here y is 10. Then you can find other cases like this. It was SFFT, this factorizing. Okay, the next one, GSFFT. SFFT is famous, more famous than this. Sometimes we have coefficient. For example, like what? You have 8xy equals 3x plus 5y plus 1. Again, x and y are integers. We want to find x and y. So, but try this one because I told you to first the basic form. Try to do it as homework 18. Homework, we had homework 18. Homework 19. Okay. So let me call it homework 19. Okay. Now let's work in this problem. We don't need GSFFT. We need only SFFT. So let's see how we can solve. Okay, let's solve this one. We have xy minus px minus qy. So I take px and qy to left side. It is 0. Now I can factorize x, y. I want to create minus px, so I place negative p. It is not equal to 0. And I want to create negative qy. I place negative q. So when you multiply, it will be pq. Okay, the problem says pq are constant when y takes its maximum possible value. When y is maximum, so this term is maximum, p and q are constant and positive. So because the product is pq, the maximum case is pq and this one 1. So y minus p equals pq. So y equals p plus pq. And if we factor from p, it will be p times. The problem wants what? Okay, why is this? It says x, y minus x. So x is what? X minus q is 1. So x is q plus 1. If we add q to both sides. The problem says y minus x. So y minus x is what? Is pq plus p minus q minus 1. Now, if we want to factorize, we can write it as p as q here. Minus q is negative 1 plus p1. P minus 1 times q plus 1, which is choice D. Okay, so the answer is this. I've told you both ideas, SFFT and GSFFT. If you want to solve more problems, as I said before, or more ideas, if you want to learn 40, 50 important formulas and ideas, in each topic, combinator is geometry, algebra, and number theory. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. Okay, problem 25. Okay, problem 25. A drinks carton is formed by arranging 4 congruent triangles like this as shown. Okay, one here, one top, one on top, one below. QPRS is 4 centimeter. Let's write them on the figure. Okay, here QP is 4, QP is 4. RS is 4 centimeter. PR is 10, PR is 10. PS is 10, PS is 10. QR is 10, QR is 10. QS is 10. Okay. What is the volume in centimeter cube of the carton? Okay, here the idea is we have some ideas when we are working in 3 dimensions. So I-17, I-18 in 3D, for example, sometimes we should use cross sections. And I will tell you a homework from AMC you can solve after this problem. So here, when we want to calculate this volume, because R is connected to all other vertices, we can calculate the height times this area over 3. The formula is this, okay? So if you want to find height, so area is easy. Area of QPS is easy. How? If you want to calculate area of QPS, it is 10, 10, 4. So it will be something like this. 10, 10, 4 isosceles. I want to calculate area. We can use Heron's formula or drawing altitudes. Because for rest of this problem, we need that. I use altitudes. So I call this one X. This one will be 2 because this isosceles triangle altitude is also median. So 2, 2. Now, if we want to find X, we use Pythagorean theorem. X squared plus 2 squared equals 10 squared. So X squared plus 4 equals 100. So X squared equals, if you subtract 4 from both sides, 96. So X equals square root of 96. 96 is 32 times 3. So it will be 16, 4 root 6. Okay. It is our altitude. Now, let's calculate this area of PQRS, area of bottom equals 4 base times height, which is 4 root 6, over 2. If we cancel 2 from both numerator and denominator, it will be 8 root 6. Now we connect S to this part, median, this altitude, this altitude. Now we consider this triangle. In this triangle, if we draw altitude, we call it R of H. Or let's write H of R. We want to find H of R. The answer of the problem is H of R times this area, which is 8 root 6, over 3. So let's calculate H of R. Let me draw this triangle. Let me call this point midpoint M, RMS. If we draw RMS, it will be something like this. It is R, it is M, it is S. So RM is this altitude. Let me erase this 4. Move it here. Okay. RM is similar to this height is X is 4 root 6. MS is also 4 root 6. So 4 root 6. And this one also 4 root 6. And RS equals 4 from assumptions of the problem. Now we want to find altitude, length of altitude through R. Okay. So let's draw this one. It is H of R. Now here, for calculating H of R, I use area. The area is what? If we copy this one and let me draw this altitude. So it is isosceles triangle. If we consider exact figure, it is this. So it is 2. Now I want to find this altitude. Y squared plus 2 squared equals 4 root 6 squared. 4 root 6 squared is 16 times 6. It's 96. And y squared, if you subtract 4 from both sides, 92. So y equals the square root of 92, which is 4 times. Sorry, if you divide by 4, it is 2 times. 2 times 4, 8, 12, 23. 2 root 23. Now, we know HR times 4 root 6 equals 2 times twice area equals this height, y, 2 root 23 times 4. Okay, we cancel 4 from both sides. And, okay, it's HR equals 2 root 23 over root 6. Okay. Now let's calculate. The answer is HR, which is 2 root 23 over root 6 times 8 root 6 over 3. We cancel root 6, root 6. 2 times 8, 16 root 23 over 3. So let's check the choices. 16 root 23 over 3. So the answer is which choice? Is choice A. Okay, now from this idea, let me tell you homework. Homework 19, homework 20. A problem from AMC. Again, in 3D, you should use two cross sections. So try this problem of AMC as homework related to 3D. Here we have cons, spheres, something like that. Okay, so in this video, we had 20 homeworks. And how many ideas? Let's see, 18 ideas. Okay, if you want to learn 18 background ideas, if you want to learn more ideas, 40, 15 important formulas and ideas in geometry, we have some formulas you should memorize. Combinatorics, algebra, number theory, background ideas, for example, 3 ideas in paths. And if you want to learn all of them and solve related homeworks, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks.